Good morning, dear students, and welcome back to our course. So far in the course, we discussed in detail about the fundamental aspect related to network theory, how to prepare uh, the course network theory as far as GATE exam is concerned, and we discussed in detail about the philosophy behind circuit theory, different types of laws which are normally used as a tool to analyze a circuit. That may be KVL, that may be KCL, then application of Ohm's law. Then we discussed in detail about different types of network theorem like mesh analysis followed by nodal analysis, then superposition theorem, Thevenin's theorem, Norton's theorem, maximum power transfer theorem, and their applications to solve a given network. Then we discussed the fundamental aspect related to AC circuit. For example, if you have AC circuit, how to solve, how to analyze those AC circuit. It may be a single phase or it may be a three phase. Then we learn in detail about the concept of basics of phasors, how to draw phasor diagram, what is the concept of lead and what is the concept of lag. And then we discussed in the last lecture of this course the fundamentals of two-port network and the resonance concept in case of series and then in case of parallel. And from today's class, what we are going to do, we will start the another course that again plays an important role as far as GATE exam is concerned. And let me tell you one thing, that this course is again common for both electrical as well as electronics and communication engineering student, and the course name is Control System. So in this particular series of lectures, our objective is to get aware about the basic philosophy behind control system, and then we are going to discuss in detail about the classifications of control system. Then we are also going to look how to create or how to develop the mathematical modeling of a system, how to represent a system. Then we are also going to learn in detail about the concepts of transfer function, then how to find the transfer function of a given system. That means we are also going to have a detailed analysis of block diagram reduction technique, then signal flow graph, where we are also going to learn in detail about the concept of Mason's gain formula. Then we will switch and enter into the time domain analysis, where objective is to do the analysis of a given system as far as time domain is concerned. There we are going to learn in detail about the concept of what is time constant, what is the concept of uh, order of a system, what is the type of a system, what are the different types of test input signals which are available with us to analyze a given system. And at the same time, we are also going to discuss the time response specification of a control system. That means what is the concept of peak time, rise time, fall time, delay time, settling time, what is peak overshoot, that we are going to cover in this particular series of lecture. Also, if time permits, we are also trying to cover how to find out the stability of a control system. That is again very important topic as far as gate is concerned. Like there are different techniques through which we can identify the stability of a control system, like Hurwitz criteria, then we have Routh-Hurwitz criteria, and then if you switch from analytical part to graphical technique, then we have root locus technique, Bode plot, Nyquist plot, polar plot. So basically these are a kind of graphical tools through which we can find out the stability of a control system. We can also make a comment uh, that for what value of gain k the system is stable, unstable, or marginally stable. And the last portion deals with the concept of state space analysis. So this is what the overall view of the course and the topic which we are going to cover in this particular course that deals with control system. So let us start with our today's session. In the first session, I'm going to take a basic aspect related to control system, what exactly control system is, and uh, what is the significance of control system, what is control in system, then what are the different components associated with a common general control system, what is the meaning of plant, what is the meaning of controller. And then we are also going to learn in detail about the classification of control system, how to classify a control system. That is very important. So first we are going to discuss what is system. So according to the course, system or a control system is nothing but a combination of different physical components which entirely act as unit in order to achieve some objective. So what is system? System is nothing but a combination combination of different physical components in order to achieve some objective. That is very important. So if you have a combination of different physical component and you design that particular unit to achieve some objective, so that unit you can treat as a system. Every physical object you can treat as a system. For example, the pen which is right now I'm holding in my hand is nothing but a system, because it is a combination of plastic material followed by nib, and then inside that it has ink, and the overall objective of this particular arrangement is to help me for writing on the paper. So that this is nothing but the example of a system. So any physical object which we can visualize, which we can see, which we are using right now are nothing but the examples of a system. For example, classroom. Classroom we can treat as a system. How? Because classroom is a combination of blackboard, then chairs, and then table. And if you club them, it is going to behave like a unit. And the objective of this particular uh, unit is to achieve or to provide a platform where a professor can deliver his lecture to the students. So you can treat that particular arrangement as a system. In the same way, because we are dealing with electrical and electronics domain, so we can take the example from electrical domain as well. So electric lamp we can treat as a system. Why? Because it is a combination of different physical component. It has glass, it has filament, and it has a support structure. And the objective of this particular unit is to illuminate a given area. So that's why we can treat electric lamp as a physical system. And the system may be of any type. It may be a physical one, it may be a biological one. Biological means what? A kind of system that is created by a god, or you can say nature. For example, human being, plants, animal, all living beings are nothing but the example of biological system. Now let us discuss what is the meaning of control in control system. What is the significance of this control? When we add this control word in system, what basic features we are going to add in the basic system? So in control system, this control is basically stand for three different functions. Number one, direction. Number two, regulation. And number three, commanding. That means if we design a system and that system is capable to perform direction, that system is capable to perform regulation, that system is capable to perform commanding on itself or some other component available in that particular system, then we can treat that particular system as a control system. So what will be the technical definition for control system? It is nothing but a combination of different physical component, because it is ultimately a system, so it has to be a combination of different physical component which entirely act as a unit. This is what the definition of system. Then we are going to add the flavor of control in that. So what control is going to do? Control is going to add three functions simultaneously. First one is to direct, second one is to regulate, and third one is to command. So if we design a system which is capable to provide direction, which is capable to provide regulation, which is capable to provide commanding on itself or some other component of the system, then we can treat that particular system as a control system. This is very important. So this you have to remember, that what is the significance of control in control system. So it is capable to perform three functions simultaneously: direction, regulation, and commanding. So once we design a system which is capable to perform these three functions, maybe on itself or maybe on some other portion of a system, then we can treat that particular system as a control system. Now, let us take the examples for control system. As we are dealing with the electrical and electronics domain, so I'm going to take the example from the same domain. So here I have shown a picture where I have connected three components in series configuration. First one is the source, of value 120 volt, second one is the switch, and third one is the lamp, or you can say bulb. Now these three components are connected in series configuration. So it is nothing but a system, because what is system? System is nothing but a combination of different physical components. So here we have three physical component. First one is the source, which is going to act as an excitation. Second one is the switch, and third one is the lamp, and all are connected in series configuration. So this is nothing but a system, and here the system is designed to achieve some objective. And what is the objective of this particular system? The objective is illumination. That means to convert electrical energy into light energy. That is important. So this is the example of a system, because it is a combination of different physical components, which include source, which include switch, which include bulb, or you can say load or lamp. And uh, the objective of this particular system is to convert electrical energy into light energy, or you can say the output of this system is nothing but illumination, to illuminate some kind of area. Now let us try to discuss why this particular system is called as control system. Now see, in the previous slide, I told you that control means this particular system is capable to perform direction, this particular system is capable to perform regulation, or this particular system is capable to perform commanding. So how we can achieve these three functions in this particular system? That we can achieve with the help of this switch. Now see here, with the help of this switch, by changing the position of switch, maybe from on to off, we are in a position to control the state of this particular lamp. For example, if the switch is closed, then in that case the lamp is in on state. That means it is going to convert electrical energy into light energy. Then second case is like when we open the switch, then in that case what will happen? The lamp stop converting electrical energy into light energy. That means the state of lamp is in off condition. That means by changing the position of this switch, we are in a position to control the state of this lamp. We are in a position to regulate, we are in a position to command the state of this particular lamp. Hence, this particular system we can treat as a control system. I hope this point is clear to everyone. Why this system is called as control system? It is a simple example of a control system where we have a source, a switch, and a lamp. All are connected in series configuration, and by changing the position of switch from on to off, we are in a position to control the state of bulb or lamp. So this is what the example for control system. Now let us discuss what are the components of a control system. For example, if you want to design a control system, then what are the basic components available in it? If you take any physical control system, it consists of mainly two components in it. First one is called as plant, and second one is called as controller. So if you take any physical control system, it consists of basic two main component. First one is called as plant, and second one is called as the controller. Now what is plant? Plant is a portion of a system. This is very important. Plant is nothing but a portion of a system whose function is to be controlled. That is important. That means सिस्टम का वो पोर्शन जिसको आपको कंट्रोल करना है, या जिसके फंक्शन को आपको कंट्रोल करना है. अगर हम previous example की बात करेंगे, the example which we take in the previous slide, where we have taken source, a switch, and a lamp, and all are connected in series configuration. So with respect to that example, plant is nothing but the bulb, or you can say the lamp. Why? Because here in this particular system, our objective is to control the state of bulb. For example, if you open the switch, then in that case the state of lamp is off. If you close the switch, then in that case the state of lamp is on. So lamp is the portion of that particular system, and our objective is to control its function. That is important. So what is plant? Plant is nothing but the portion of a system whose function is to be controlled. So with respect to previous case, in our system, lamp or bulb is going to act as a plant of that particular system. Now, what is controller? From the name itself, it is very clear that it is nothing but a kind of a device, or you can say element, whose function is to control the action of plant. So what is controller? Controller is nothing but the element of a system. This is very important, whose main function is to control the action of plant. Now, it is not at all necessary that controller is always going to be available inside the system. It may possible that the controller uh, may available outside the system or may available inside the system. But ultimately, the objective of controller is to control the action of plant. Now, with respect to previous case or previous example, uh, switch is going to act as a controller. Why? Because by changing the position of switch, we are in a position to control the state of lamp, which is nothing but a plant. Hence, switch is going to act as a controller and lamp is going to act as a plant. Plant is a portion of a system whose function is to be controlled. Controller is the element which may present inside the system, which may not be present inside the system. But ultimately, the main objective of using controller is to control the action of plant. That is important. So if you apply this topology in our previous case, so instead of writing switch, now we can write that switch as controller. And instead of writing bulb or lamp, now we can write that as a plant. So this is what the representation of a control system, where we have a combination of controller followed by plant. And to this particular system, we need to provide some input in the form of excitation. So the input which we have provided to this system is nothing but electrical energy of 120 volt. So this is going to be the input. Sometimes this is also called as excitation, or you can say input. Both are nothing but the same thing. And when you provide this input or excitation to this particular system, it is going to generate some output which is called as response. So output or response in this case is nothing but light energy. So this is called as output, or you can say response, which is very important. And if you open this particular system, again, you have a combination of two fundamental component in it. First one is called as plant, which is the portion of system whose function is to be controlled. And second one is controller, which is nothing but the element available in that particular system through which we are going to control the action of plant. That is important. So this is the example of your control system. I hope this point is clear to everyone, why this particular system we can treat as a control system. So once you know the fundamental aspect of plant, once you know the fundamental aspect of controller, then we will discuss the meaning of disturbance. What is disturbance? And what factor leads to have disturbed signal in case of a system? So disturbance are nothing but any unwanted signal. Let me clear this thing. Any unwanted signal that basically going to affect the performance of a system or a control system, those unwanted signals we can treat as a disturbed signal, indicated by symbol small d. Or if you are trying to define that disturbed signal in case of time domain, it is going to be small d of t. Or if you try to define that in frequency domain, it is going to be capital D of S. So this is the representation for disturbed signal in time domain, and this is the representation for disturbed signal in case of frequency domain. So what is disturbance or disturbed signal? They are nothing but a kind of unwanted signal which basically going to affect the performance of control system. Now, depending upon from where these sources are generating in the system, based on that we can have the flexibility to classify disturbed signal into two main domain. First one is called as internal disturbances and second one is called as external disturbances. Now, what is the meaning of internal disturbances? From the name itself, it is clear that internal disturbances are nothing but a type of disturbed signal which are created in the system and their source are available inside the system itself. For example, if we have a system and inside the system a source is present which is responsible to create that disturbed signal, which is nothing but d of t, and this disturbed signal is basically going to affect the output of the system. For example, the input is say X, and corresponding to this input the system has to generate Y as an output. Now because of this disturbed signal, instead of generating Y as an output, the system is now generating Y1 as an output. So this is what the effect of disturbed signal on the performance of a control system. So this is nothing but internal disturbances, because the source of these type of signals are available inside the system itself. But in case of external disturbance signal, the source is available outside the system. For example, if you have a system and to this system you apply some input in the form of excitation, say X, and corresponding to that, this system has to generate output, say Y. Now somewhere over here we have the source of disturbed signal, and this disturbed signal is going to generate some unwanted signal which is going to act as an additional input along with the main input signal, say D of T. And this particular system performance is going to affect due to the presence of this disturbed signal. So instead of generating Y, now suppose it is going to generate Y1 as an output. So because the source of these unwanted signals are available outside the system, some external agency is responsible to generate these type of unwanted signal. Hence, they are called as external disturbances, which is very important. So the same thing is mentioned over here. See, internal disturbances are nothing but so these type of signals are generated inside the system only, and basically they are going to affect the performance of the system. And external disturbances are nothing but the sources of these signals are present in not present inside the system, they are present outside the system, and they are going to act as an additional input along with the main reference input, and they are basically going to affect the overall performance of the system. So they are nothing but external disturbances. So I hope this point is clear to everyone what is disturbed signal and how to classify disturbed signal. Once you have done with this, let us try to understand how to represent a control system. That means general block diagram representation of a control system. So basically control systems we can represent in two different domain. First one is called as time domain and second one is called as frequency domain. So this picture indicate the basic general block diagram representation of a control system in time domain. Now how to identify whether the system is represented in time domain or not? Just look the reference input signal and the controlled output signal. Reference input signals are normally indicated by symbol small r of t in case of time domain representation. Now this input, when you apply it in the form of excitation, depending upon the objective of this particular system, it is going to generate some controlled output as a response, and the controlled output are indicated by symbol small c of t. So whenever in the representation of a control system, if we used small letter like small r of t, small c of t to indicate the reference input and the control output respectively, then that kind of representation of control systems are nothing but time domain representations. So these are standard representations, and throughout the course we are going to follow these representation symbol, so that you have to remember. Like small r of t indicate the excitation, or you can say input, and small c of t indicate the controlled output or the response of this particular system. In the same way, if you are interested to represent the block diagram of a control system in frequency domain, so how to represent that? It is going to be like this. Again, we have a rectangular block. Inside that block, we have indicated that is going to be a control system. So if you open this block, here you have a combination of plant followed by the controller, and to this system we applied some input in the form of excitation. Now here, because we are dealing with frequency domain, now we need to use capital letters like capital R of S. So this indicate your reference input signal, or you can say excitation. So when you apply this reference input signal or excitation to this particular system as an input, it is going to generate some controlled output in the form of response. Now here we need to indicate capital C of S, or use capital C of S to indicate the controlled output. So this point you have to remember, that in case of time domain, the reference input signal are indicated by symbol small r of t. But in case of frequency domain, the same reference input signal we are going to indicate by capital R of S. Reference input is also called as excitation. Excitation means input. This is very important. And then in time domain, the controlled output signal are indicated by symbol small c of t. But here the outputs are indicated by capital C of S. So this you have to remember. So whenever we are dealing with the time domain representation of a control system, we are going to use small letters with T in bracket just to indicate that all the signals are time varying, or they are going to vary with respect to time. Whenever we are trying to represent the system in case of frequency domain, we are going to use capital letter in bracket S, where S indicate your frequency domain representations. So this point you have to remember, because these are very basic fundamental aspect which plays an important role to understand this particular subject in detail. Now let us try to understand the classification of control system. How to classify control system. So far we discussed what is system. It is nothing but a combination of different physical components to act as a unit to achieve some objective. What is the significance of control in that particular system? So when we add control, that means the system is capable to direct, to regulate, and to command itself or some other portion of the system. Then we discussed the example of a control system, followed by what is the meaning of plant and what is the meaning of controller, and how to represent control system in time domain and then in frequency domain. Now, how to classify control system? So control systems are basically classified into some 8 to 9 different category, and out of these 8 to 9 category, I have highlighted some uh, types of control system, like serial number 4 that deals with time variant and time invariant control system. Then serial number 5 deals with linear and non-linear control system, and serial number 9 deals with open loop and closed loop control system. So these three types of control systems or their classifications are very much important as far as gate exam is concerned. So if you refer previous year gate questions paper, in most of the cases, what are the type of systems that are given to us, maybe for identifying their stability, maybe for finding their time responses, or maybe for finding any kind of parameters, by default they are nothing but belonging to these three different category, like time variant, time invariant, linear, non-linear, open loop control system, and then closed loop control system. And because we are preparing for the gate, hence our objective is to understand these three type of control systems, or these three domain, to classify control systems in detail. That means from uh, the remaining portion of this particular class, basically we are going to focus on understanding the fundamental aspect of what is time variant and what is time invariant control system. Then we are also going to learn what is the meaning of linearity, what is non-linear control system, how to identify that, suppose if you have a physical control system, whether it is linear or non-linear. In the same way, we are also going to learn in detail about the concept of open loop followed by closed loop control system. Apart from this, let us try to make a quick discussion on what exactly this natural control system, man-made control system, combinational control system, then continuous time and discrete time, lumped and distributed. Then we have a single input, single output, then multiple input, multiple output. This MIMO stand for multiple input, multiple output system. So natural control systems are nothing but a kind of control systems that are designed by God, or they are naturally available in our environment. Example, all living beings, human, plant, animal are the example of natural control system. Now man-made control systems are also called as artificial control system. Artificial control system, they are designed or created by the man or human activity. Then combinational control system is nothing but a combination of natural control system and artificial control system, or you can say man-made control system. For example, in most of the cases, in most of the physical cases, a system is nothing but a combination of man-made and natural control system. For example, if you take a driver driving a car, so car is nothing but the example of man-made control system, but driver, which is nothing but a human being, is the example of natural control system. When a driver is driving a car, so that entire structure you are treating as a unit, and in that unit we have a combination of natural control system, which is nothing but driver, followed by man-made control system, which is nothing but the car. Hence we can treat that particular system as a combinational control system. You can take any example, there are huge a lot of examples I can give in this particular domain. Then let us try to discuss what exactly the meaning of these three highlighted classifications of control system, like time domain, time variant, time invariant, and linear, non-linear, and open loop and closed loop control system. So the first portion is time variant and time invariant control system. Now, see here, this variancy or this invariancy we are going to define in case of control system based on the parameters of a system. Parameters of control system. For example, what is time variant? If the parameter of that system is going to vary with respect to time, then that system is known as time variant control system. What is time invariant control system? If the parameter of that system is not going to vary with respect to time, even though input and output are the function of time, then it is known as time invariant control system. So this is very important. So this variancy or invariancy with respect to time we are defining with respect to the parameter. So if we have a kind of control system where the parameter of that system is not going to vary, that means once we have designed the system, the parameter values are fixed, they are not going to change even though input and output are the function of time. So that is, you can define as time invariant. In some cases it may possible that in control system the parameters are the function of time even though input and output are not the function of time. Input is constant, output is constant, but the system parameters are going to vary with respect to time. So that we can treat as a time variant control system. That is very important. So what is a time variant control system? So in time variant control system, as I told you, that the parameters of the systems are going to vary or they are going to change with respect to time, even though, this is very important, output and input are not the function of time. So those type of systems are called as time variant control system. And the example is launching of spacecraft is the best example for time variant control system. Now why? What is the reason behind that? So let us have a discussion on this. This particular topic I think we all learn in our 10 plus 2 in 11th or 12th standard physics, then how to launch a satellite, the basic fundamental aspect. So basically the spacecraft we can classify into three different stages or three different portions. Portion 1, then we have portion 2, and then we have portion number 3. Let us consider that each portion have some mass, say m1, say m2, and then say m3. Now this m1, m2, and 3 indicate the mass of each portion, and we know that mass is nothing but one parameter of a system. And here the input to this particular system is nothing but the fuel, and the output of the system is nothing but the speed. So output is speed and input is nothing but fuel. Now suppose if the launching of this particular system begins, so what will happen? Initially, up to certain distance, this particular system is going to move in the upward direction, and up to certain distance, maybe say 1000 kilometer above the earth surface, or 2000 kilometer above the earth surface, the third portion of the system get detached from the main system. So the moment we have the detachment, so this m3 is not going to be there in the picture. Now the overall weight of the system is nothing but a combination of m1 and m2. So I can say that the parameter of the system is not going to be a combination of m1, m2 and m3. Now it is only m1 and m2. In the same way, after a certain duration of time, when stage 2 get initiated, then in that case what will happen? This portion get detached from the main system. Now we have only m1 in the picture. And then when the last portion is detached, so somewhere over here we have the satellite, so last portion get detached, so we have only satellite mass available over here, which is nothing but say ms. So I can say that the moment the system get initiated, with respect to time, the parameter, which is nothing but mass in this case, is going to vary with respect to time, even though the fuel and the speed are almost going to be independent of the time. Then this type of system we can treat as a time variant control system, because in this case the parameter of the system is going to vary with respect to time. This is very important. In the same way, let us have a discussion on time invariant control system. So what is invariancy? Invariancy means what? The system is not going to vary, or the system parameter is not going to vary with respect to time, even though input and output are the function of time. Example is in electrical circuit. For example, if you take a series RLC circuit where we have a resistor of value say 1 ohm, then inductor of value say 10 millihenry, and a capacitor of value 100 microfarad. And to this system we need to provide some input in the form of excitation. So we have applied some input in the form of voltage, say v of t, where small v of t indicate the instantaneous value of the voltage. And the moment we connect an AC source across this series RLC combination, path is completed, we have a potential difference, so definitely there will be a flow of current through this circuit, and that instantaneous value is say I of t. Now see here, once we have designed this particular system, once we have decided that what is the value of R, what is the value of L, what is the value of C, the value are not going to change with respect to time. If you design the circuit at this moment, R is going to be 1 ohm, L is going to be 10 millihenry, and C is going to be 100 microfarad. The same circuit, if you check the value of RLC tomorrow morning, again they are going to be 1, 10, and 100 respectively. In the same way, if you check the value of RLC after 1 month, again they are going to be 1, 10, and 100 respectively. In the same way, if you check the value after say 6 months, or even after say 1 month, if 1 year, if you ignore the aging effect, the values of RLC are like 1 ohm, 10 millihenry, and 100 microfarad respectively. But in this case, the input, which is nothing but excitation V of t, and the output, which is nothing but response I of t, are the function of time. Here, V of t and I of t are continuously varying with respect to time. At t equals to 0, voltage is 0. At t equals to say 2.5 millisecond, because if you consider the frequency as 50 hertz, so 1 by 50 is going to be 20 millisecond, that is for one time period. Half of that is 10, and then wait for a minute. और सर उसमें कैसे का पेट्रोल डलवा देना है उसमें। अरे रुको ना। So, sorry for the disturbance. Okay, so we are discussing this concept of time invariant control system. So, series RLC circuit is going to be time invariant because once we have decided to design this particular system, the value of RLC are going to be almost constant irrespective of time. That means if you check the value of RLC at this moment or after 1 year, the values are almost going to be the same. But the voltage applied to the circuit and the current flowing through the circuits are the function of time. Hence, this is the example for time invariant control system where the parameter of the systems are not the function of time, but the input and the output are going to vary with respect to time. So this slide indicate the representations of time variant and time invariant control systems. So here, see, in case of time invariant control system, the parameters time invariant, the parameters are not the function of time. But in case of time variant, the parameters are the function of time. So because here parameters, let us consider that I can represent this as capital P of t. So here parameters are the function of time, even though the input and output are not the function of time. So here we need to write only small r and only small c, or you can write capital R or capital C. Suppose if you write that in frequency domain. But in case of time invariant, here parameters are indicated by symbol capital P. They are not the function of time, so no need to write P of t. But here, the input and output are the function of time. So see, I have written here small r of t. So small r of t indicate that it is the representation of input signal in time domain, and that is the input is a function of time, and based on that it is going to generate some output again in time domain, and that is also the function of time. That's why I have written here small r of t and small c of t. So small r of t indicate the reference input signal which is going to vary with respect to time, and small c of t indicate the controlled output signal that is also going to vary with respect to time. And for ease in calculation, in general, we consider all systems to be time invariant control system. This is very important. And as far as gate syllabus is concerned, whatever the kind of systems that we are going to learn, that we are going to take, maybe for analysis purpose, maybe for finding the transfer functions, maybe for finding the responses in frequency domain or in time domain, by default all are nothing but time invariant control system. That means we need to deal with these type of systems only. That means the system parameters are not going to change. Once we have designed the system, the parameters are almost going to be constant. They are not going to change with respect to time, but input and output are the function of time. So those type of systems are called as time invariant control system. Then the second portion deals with linear and non-linear control system. Now, what is linear control system? A system is said to be linear if it is going to follow principle of superposition. And if it is not going to obey principle of superposition, the system is said to be non-linear. Now, what is the meaning of this principle of superposition? A system is said to obey principle of superposition if it is going to follow two properties simultaneously. First one is called as additive and second one is called as homogeneous. That means अगर आप कोई सिस्टम को आइडेंटिफाई करना चाहते हैं कि वो लीनियर है कि नॉन लीनियर है, तो पहले ये पता करो कि वो सिस्टम प्रिंसिपल ऑफ सुपरपोजिशन को फॉलो कर रहा है क्या। अगर कर रहा है तो वो हो जाएगा आपका लीनियर, अगर नहीं कर रहा है तो वो हो जाएगा आपका नॉन लीनियर। अब अगर वो कर रहा है, इसका मतलब कि उसे दो प्रॉपर्टीज फॉलो करना है, एक रहेगा आपका एडिटिव और दूसरा रहेगा आपका होमोजीनियस। दैट मीन्स इफ अ सिस्टम is obeying additive property, obeying homogeneous property, that means it is going to follow principle of superposition. And if it is going to follow principle of superposition, by default that system is going to be a linear control system. If it is not, then we can treat that particular system as non-linear control system. This is very important. Now let us try to understand what is the significance of this additive property and homogeneous property in terms of pure mathematics. Now suppose if we have x and y which belongs to domain of function f, then if x, y are additive, so we can write that in this particular equation like f of x plus y is going to be f of x plus f of y. In the same way, suppose if we have x that belongs to domain of function f and we have another scalar quantity or constant value, say capital A, then this is said to be homogeneous if we deal with this particular equation like f of a times x is going to be equals to a times f of x. So if these two equations mathematically satisfied, we can treat that particular function as obeying additive property and homogeneous property simultaneously. Hence we can treat that particular system as a linear system or a linear function. Now let us try to discuss what the physical significance of this. What is the meaning of additive property in terms of system? So what we are going to take, we are going to take a general control system. Suppose we have a general control system and we need to identify that whether that system is additive or not. So what we are going to take, so here I have taken a general control system and to that particular system I have applied some reference input signal and the reference input signal is R1 of t. So when we apply R1 of t as an input to this particular system, it is going to generate some controlled output in the form of response, which is nothing but C1 of t. So this is case 1. Now what we are going to do, we are going to take case 2 in which we are going to change this input. So instead of taking R1 of t, now we are going to take R2 of t and that R2 of t is provided as an input to the control system. And based on that, this same system is going to generate some controlled output. Let us consider that the output is C2 of t. Now in case 3, what we are going to do? We are going to provide the addition of these two inputs simultaneously like R1 of t and R2 of t. So we need to club these two and we are going to provide that as an input to the system and we are going to examine that what will be the output of that particular system in that case. That means case number 3. If the output of the same system in case number 3 is like a combination of C1 of t followed by C2 of t, or you can say individual addition of responses produced by the system in the previous two cases, then we can treat this particular system as additive. कहने का मतलब है कि मान लो आपके पास में एक सिस्टम है, वो सिस्टम को अगर आपने कुछ इनपुट दिया से x1, उसने प्रोड्यूस किया आउटपुट y1. नाउ सेम सिस्टम को आपने इनपुट दिए x2, उसने प्रोड्यूस किया आउटपुट y2. अब अगर मान लो आप x1 x2 को ऐड करते हो और कलेक्टिवली इनपुट प्रोवाइड करोगे, तो वो केस में अगर वो सिस्टम y1 y2 का एडिशन प्रोड्यूस करेगा तो मैं बोल सकता हूं कि वो सिस्टम आपका क्या है, लीनियर है. सेम लॉजिक वी हैव अप्लाइड ओवर हियर. सी, so instead of providing R1 of t, now we have provided R2 of t as an input and we are trying to find out the output of the system. So output is going to be C2 of t for the input R2 of t. Now we have provided the combination of R1 and R2 and we are trying to find out the output. So here the output is again the combination of C1 of t and C2 of t. So hence we can treat this particular system as additive in nature. Additive in nature, or it is going to follow additive property. In the same way, let us try to examine what is homogeneous property. Again, we have taken the same system, that is control system, and to this system we applied some input in the form of R of t and we are trying to find out the response and the response is C of t. Now what we are going to do, we are going to manipulate this input signal by some factor. Suppose I am going to manipulate the input signal by factor A. So now in the second case, I'm going to provide A times of R of t as an input. Now based on this particular input, the system is going to generate some output. Suppose the output is again going to manipulate by the same factor like A. Then we can treat this particular system as होमोजीनियस. सो होमोजीनियस का मतलब क्या है कि अगर मान लो आपके पास में एक सिस्टम है, उसको अगर आप कुछ इनपुट देते हो तो वो आपको कुछ आउटपुट देगा. अगर मान लो आपने इनपुट को एक पर्टिकुलर फैक्टर से मैनिपुलेट किया, मे बी आपने उसको मल्टीप्लाई किया, मे बी आपने उसको डिवाइड किया, या जो भी एक्शन आप इनपुट एंड पे अप्लाई कर रहे हो, सेम एक्शन आपको आउटपुट एंड पे भी अगर दिख रहा है तो आप बोल सकते हो कि वो सिस्टम आपका क्या है, होमोजीनियस है. नाउ सी हियर, सी in this case we have manipulated the input by a factor A, so the same factor is going to appear across the output. This is C of t, which is nothing but the output in the previous case when we provide R of t as an input to the system, and here in case 2 we have manipulated the input by a factor A, so the same factor is appearing over here in the form of response. Hence we can treat this system as homogeneous system, or you can say the system is going to follow homogeneous property, where A is nothing but a scalar constant. Now because this system is going to follow both the properties simultaneously, it is additive in nature, it is homogeneous in nature, so we can treat this particular system as following superposition property or principle. Hence we can treat this particular system as a linear control system. I hope this point is clear to everyone. And still, if you have some issues, let us try to take a physical example. Let us try to take a practical example of a system, and let us try to find out whether that particular system is linear or non-linear. And because we are dealing with electrical and electronics domain, so we are going to take a simple uh, system like a resistor, and the value of that resistor is say 1 ohm. And to this particular element, which is nothing but our system, we are going to provide some input in the form of excitation. Let us consider that the value of I may be say 10 ampere, or it may be say 20 ampere, and we are going to identify whether that particular system is linear or not. So once we provide I through this resistor, it is going to uh, create some voltage. We are going to experience a voltage across this resistor, and the value is say V. So this V is going to be the output of the system. I is going to be the input of the system, and this R is going to be the element of the system, or this is nothing but what our system is. And our objective is to check whether the resistor of value 1 ohm is linear or non-linear. So far in your fundamental course, you have learned so many times that resistor is nothing but a linear element. Now we are discussing why resistor is nothing but a linear element. Again, whether it is a element or it is a system, property remain the same. That means a element is said to be linear if it is going to follow superposition principle. That means it has to follow two conditions simultaneously. It must be additive, it must be homogeneous in nature. So let us try to apply the concept of additiveness, the concept of homogeneity in case of pure resistor, and try to identify that whether it is capable to obey those principles or not. So see, here I have taken a resistor of value 1 ohm, and that is placed in the block. So this is going to be our system, and to this we applied some input in the form of excitation, that is nothing but current I1, and the value is 10 ampere. If you apply Ohm's law, you are going to have V1 as an output, which is nothing but I into R, and that is going to be equals to what, 10 into 1, that is 10 volt. So when we apply 10 ampere current to this resistor, it is going to generate 10 volt as an output. Now what we need to do, we are going to change the input, keeping the system same. So see, same resistor of 1 ohm is placed over here. Now we increase the value of voltage, current. Instead of providing 10, now we are providing 20 ampere as an input. And based on that, it is going to generate some output, which is nothing but V2, which is 20 volt. Now in case 3, what we need to do, we need to add these two inputs simultaneously. So we need to add I1, we need to add I2, and the addition of these two we are going to provide as an input to this particular system. So if you provide the addition of I1 I2, so 10 plus 20, this is going to be 30. So 30 into R, this is going to generate some response which is nothing but V. I into R, it is going to be 30 volt. Now this 30 volt I can bifurcate as 10 plus 20. Now this 10 is going to be V1 and 20 is going to be V2. So this is V1 plus V2. Hence this is going to obey additive property, because I told you that additive means what? If you apply some input to a system, it is going to generate some output. If you change the input corresponding to that, it is going to generate some output. Now if you supply the collective of the input which we have taken in previous cases, and if you provide them as a common combined input, it is going to generate some output. If the output is nothing but the addition of individual inputs produced by the same system in the previous cases, then we can treat that particular system as additive. So same thing is happening over here. Hence we can conclude that resistor is going to obey additive property. Now let us try to find out whether that is going to obey the homogeneous property or not. Again, we have taken the same system. Same system means R is going to be 1 ohm, and to that we apply some current in the form of excitation, that is nothing but input, and the value is 10 ampere. And based on that, it is going to generate some output. According to Ohm's law, it is going to be I into R, that is nothing but 10 volt. Now what we need to do, in order to check the homogeneity, we need to scale up or scale down, or we need to manipulate the signal, input signal, by some factor. So here we have manipulated the input by a factor of 5. So instead of providing input 10 ampere, now we are providing 5 into 10, that is nothing but 50 ampere as an input. And based on that, it is going to generate some output which is nothing but I into R. I is 50, R is 1, so it is going to be 50 volt. Now this 50 volt I can write as 5 into 10 volt. Now this 10 volt is nothing but what? The voltage produced by the system in the previous case. So it is going to be 5 times V. Now see here, in this case we have manipulated the input by a factor of 5. The same manipulation is going to be appear across the output. That means a pure resistor is going to follow the property of homogeneity. And in the previous slide, we discussed that a pure resistor is going to follow the property of additiveness. So here we conclude that a pure resistor is going to follow the property of superposition, because it is going to follow the property of additiveness and homogeneity simultaneously. Hence, we can treat this system as a linear system. That is the reason resistor is nothing but a linear element. I hope now this point is clear to everyone, and from this lecture onwards, now you don't have any confusion why resistor is called as a linear element, why it is not a non-linear. Because a resistor is going to obey homogeneous property and additive property simultaneously. Because it is going to obey both properties simultaneously, that means it is going to obey superposition property, hence it is linear in nature. And to have a ease and analysis purpose, for analysis purpose, what we consider that all physical systems are going to be a linear control system. This is very important. So as far as gate is concerned, whatever the type of system that we are going to deal in the coming classes, all are by default linear in nature. This is very important. And in the previous slide, I told you that by default we are going to take the system as time invariant, and here I told you that by default we are going to take the system as linear. So it is going to be like a linear time invariant control system. So these type of systems we are going to take in the further classes to examine different aspects of control system. So whenever we have a control system and our objective is to find its transfer function, our objective is to find its time domain analysis or frequency domain analysis, or to study the impact of controller on the behavior of the control systems, or in state space, by default the systems are nothing but linear time invariant. Linear means it is going to obey the property of superposition. Time invariant means what? The parameters are not the function of time, even though input and output are the function of time. In the next lecture, we are going to discuss the other classification of control system, which is considered to be the most important classification of control system, that is open loop control system and closed loop control system. Thank you.